Welcome back to Disruptive RX with Dr. Inderpal Randhawa. I'm Sean Andre, as always, joined by the great disruptor, not just in the world of healthcare, but in so many other spaces as well.
It's
Dr. Inderpal Randhawa.
Thank you, Sean. Yeah, it's kind of like you get bit by a bug or something, and it's
Right.
just like everything has to be disrupted.
Right.
There's an old saying, right? If it ain't broke, don't fix it.
Yes.
So I'm definitely trying to wear that hat sometimes. But
Right.
as for this episode today, super excited because this is, I think, core to me and who I am as a disruptor. Uh, Building an organization from scratch that is going to deal with some of the most complicated questions in the disease space is no easy task. It took a
Sure.
lot,
Sure.
but I mean, here we are, literally a decade and a half later, and we're in an amazing place. So it's good
Right.
to have Dr. Marsteller back as well.
Dr. Nathan Marsteller, you're back. Thank you for coming back to join us.
Thank you for having me.
Director
Great to be here.
Absolutely. Director of Research at the Translational Pulmonary and Immunology Research Center. So, Dr. Randhawa, when you find or when you're looking for a director of research, what qualities are you looking for? Are you looking for somebody who's also going to be disruptive in this space?
I've had the experience of working in many, many institutions, and I'm talking, big name institutions, Stanford, and many others. And I've worked under many different research scientists, and I've worked alongside many different research scientists. And what I was always bothered by was the scientists who are out there just essentially trying to get their name in the next step up.
Mm.
So what that meant was they're trying to get in the next committee, they're trying to get in the next grant cycle, they're trying to move up in the institution. And as they were focused on that, they lost sight of what they were trying to study. They were lost sight of the mission of what they're trying to work on. And I worked with this one gentleman who I will not name, who and I helped him build up his lab, and we were working in this particular kind of asthma, and he published this work. And I remember working in his lab and seeing how quickly he became sloppy.
Mm.
How quickly he suddenly didn't have these results that he talked about at his fingertips. Sure enough, down the road, no one could reproduce his work, and he could not even reproduce his own work. And he left that university, for that reason. So I knew that in order to work with anybody in the space of science, we had to be really diligent, very detail oriented, and highly focused, and focused on our mission, which means that we're going to study a disease in total, full stop.
Mm.
We're going to look at it from the clinical and population side to the middle translational side, all the way to the molecular and scientific side. And that's a huge ask of anybody, right? To say, hey, look, we're going to take the whole thing. And, there's not a lot of people who would have the guts to even try.
Right.
And then there's this guy.
Yeah. Yeah. I mean, your passion for every minute detail. Did you think you were going to find somebody like Dr. Marsteller? I mean,
Honestly, no. I thought it was going to take a long time. I thought, I'd say even now, I'm sure you agree, it's not easy to continue to find people like that.
Sure.
Right. And so you can't have that expectation, but sometimes you're fortunate. So I think I was fortunate. And now we continue to grow.
Right.
But ultimately, we hope that, podcasts like this get out there and get people engaged, because I know they're out there.
Mm-hmm.
Right. I mean, Dr. Marstow was out in Lincoln, Nebraska, and we found him, and now we hope to find other people globally who are interested in this kind of work, our approach, and we want them to join us.
Do you think of yourself as a disruptor in this space and dealing in rare and orphan diseases?
Yeah, I guess it's definitely we have a different approach, and as Doc alluded to, it definitely fits my style more. I would say we still rely on scientists that are very much focused on, maybe a single polysaccharide on a single microbe and how that impacts the host, and they spend 30 years on that. But that's just not the way my mind works. I like to think of whether it's the disease state as a whole, or even like what makes something healthy. I think that's always sometimes it's even more challenging. It's one thing to describe a disease state, but how do you define what true health is? And so to be lucky enough to find a spot where Doc and I both are kind of on the same page in that regard of really looking at lots of different things all at once was definitely a big fit for me. And so, yeah, I would say that's definitely disruption of the kind of the way a lot of academic institutes do it. That's for sure.
When I first met you, I'm an old school radio guy, and I first met you, and you said, "Hey, Sean, do you want to look at something really cool?" And you showed me this mouse model with this CPAP machine
Oh, yeah.
and these little tiny masks that you created for that. Can you expound on what you created with this mouse model and how that's helping you and dealing with rare and orphan diseases?
Yeah. So bronchopulmonary dysplasia is a pulmonary disease, so lung disease that affects premature infants. And in that acute phase, fortunately, about 20 years ago, we started using CPAP. So if someone has sleep apnea, it's same things, continuous positive airway pressure. In the acute phase, it's way better than what had previously been used, which is intubation, getting put on a full respirator. But what we didn't really understand is how CPAP could impact the lung at the structural level and how that might impact chronic disease later in life. And so in this moment, we had to set up an animal model so that we could study this. And but you can't just go to the store and buy CPAP units for baby mice.
They don't
So
exist.
yeah, so we had to go about making it. So I got some help getting the flow meters built up to get that oxygen flow. But then I had to build the masks, and so it was actually kind of nice just to go tinker at a workbench and yeah, get a bunch of basically had to make helmets because the infants in the hospital, they're getting a nasal CPAP, but a little pup, there's no way you're going to be able to get a little mask on their nose. So we had to do a full helmet. So it's basically just taking a 10 mil syringe, pulling the plunger out, hacking off one side, get airflow drilled in here, and then the other airflow goes into where the needle would go, and then you have basically, I don't know if you ever mess with a carburetor on a motorcycle or something like that. You just have a manometer that basically assesses the pressure, and you could do that in the lung as well. So if you're at the hospital, it's all digital, but it's essentially the same fluidic system inside, where it's 1 atmosphere of pressure, and you measure that difference, and that's the water column. And so we build all that in, and throw it on the mice, and it's working well. And where I think it's going to have huge impacts, both at the bedside and in the basic science avenues of just getting an understanding of the changes that CPAP could have on the developing lung. So we could look at it structurally, we could look at it at the cellular level, and we could look at it at the molecular level.
What's the connection here, Dr. Randhawa? You're also a transplant immunologist. What is the connection here with what he does?
Yeah. So we're talking about a disease that you would find in premature babies, right? So a disease that's been described really since the 1950s. It impacts the numbers are all over the place in the US, but it's probably somewhere around 100,000 babies, maybe slightly less than that. So you'd call that a rare disease, right? It's less than 1% of the total population. But you talk to any parent who has to deal with this small baby who was born premature, who now is not having normal lungs, and how long that lasts. That disease not only affects them when they're just a few months old, it affects them when they're 3 years old, 5 years old, 10 years old, even as an adult.
Wow.
And in all the 50 plus years or more that they've been studying this, we have a total of 0 treatments for this disease.
Wow.
So all we do is support them and hope it gets better. So we first started with this question, right? Again, it's all about disruption. It's all about applied math, collecting information and data, understanding how that data connects across humans to different models all the way to the cell side. And so this is what's been built really in the last 5 to 6 years. And Dr. Marsteller is not giving himself credit here. He came into this organization and had very little pulmonary experience. And he literally spent probably the first year of his time here training under Pulmonary, going up to USC, spending a lot of time in the laboratory there, and in a very short period of time became an expert in the space, right? And that's what the level of desire that's necessary to make things move.
Sure.
And so now here we are a number of years later, and we built really one of the few models that's looking at this condition. So what does that do for the individuals, the patients out there who are struggling with this, the families, is that we can very shortly here look at potentially modifying the way we treat these babies with all of this respiratory support in the NICU and likely have a really different outcome, meaning not the severe lung disease. Maybe we can make it better by 50%. Maybe it can be better by more. But this is the kind of immediate success you can have, which is the mission of our organization. We do the research quickly. We find, the proper answers that help patients today, not 30 years from now.
Right.
Let's figure that out. And I just say one last thing. By building such a really broad system across one disease, now we have targets. Maybe it'll be a drug target. Maybe it'll be another type of immune target. It'll be, some other target. And this goes back to my immune system, immune transplant background.
Okay.
We're always looking for targets. And we just need one target, and we can move that towards the next step of drug therapy. But in the meantime, we're still making sure these patients have a better outcome. That's really kind of, in summary, what we do.
It almost seems like 6 degrees of separation because it's all seemingly interconnected with what you've done in transplant immunology and then with what he's done. And there is a correlation there, it seems like.
Yeah.
Yeah.
I mean, it is, right? In the sense that if you're in the transplant space, as I always say, you're the last person in line, right? They're not talking to anybody else. You're the last person, and after that, there's nothing. You're talking about these infants, these babies who, again, I mean, if you look at a parent who finally has a child, and now this child is going through the worst of the possible health experiences, we have to do something for these infants. So we have to take our approach of this kind of last person standing and say, okay, we're going to try everything possible to study and find a solution. And I'd say that is an equal parallel. Whether you're in the transplant space or you're dealing with rare disease, you are the last person. And if you don't take that seriously, then you should just get out of that space.
Are you amazed by the lack of passion when it comes to even some of your colleagues wanting to take on this? It's a big task, but the lack of
Surprised?
yes, yes,
I'm not surprised. And in many ways, I don't blame them. It is a lot, right? It's a huge burden to carry when you're dealing with this kind of work. And it comes down to how much can individuals handle, right? So you're a physician or you're a research scientist. How much can you handle in a day? How much are you willing to take on? What is it doing to your health? What is it doing to your finances? What is it doing to your family? And I'm built how I'm built, and I wanted to solve these questions, and I have my story for that, which you can go to the first podcast for, by the way.
yes, yes, yes.
But
Nice plug.
but my point is, I really feel that you cannot disassociate yourself from these folks. To be very frank, when I first started in the work, I had that mentality. I would say, you know what, if you don't share my passion for this, get out of my way.
Yeah.
And that was a very serious mistake, all right? Because you cannot build organizations and solve problems if you don't bring anybody in who even has an inkling of interest. You got to bring them all on board to whatever capacity, and then it's up to us to build the right type of organization and flow to get success.
Dr. Marsteller, how often do you visit the NICU? You're so laser focused on what you do and your research. Do you ever take time to just go and see, okay, this research that I'm doing, this is leading to, it's going to be a cure for something, or it's going to help these preemie babies in the future. Do you ever take time to go to the NICU?
I'd actually like to get over there more often. I was spending more time over there pre-COVID, and since then, it's been a little bit less. I'm over in the pulmonology division pretty often. Now that we've got Dr. Modisham on, we were really lucky to have her. She came from one of the biggest BPD centers on earth over at CHOP in Philadelphia. And now she's kind of bridging the gap between the NICU and the pulmonology division. So hopefully I'll have more time to get over there in the future.
Oh, yeah. So other rare diseases, rare and orphan diseases, CF and bronchiectasis. Can you talk about your research and what you found with that?
Yeah. We've had a few different studies over the years in the cystic fibrosis space. Of the most recent that's still percolating right now is looking at the impact of neutrophils. And one thing that's really important when you're working with these rare and orphan diseases is trying to find commonality between different diseases, because there's only so many dollars out there, there's only so many hours in the day. And if we're going to have a big impact on a large number of patients, finding that commonality is really crucial. So to that end, we're really working to get a better understanding of neutrophils. They're part of the innate immune system. I'm guilty of this as well as an immunologist. A lot of immunologists really are fascinated with the adaptive side. They focus on T cells and B cells, and can really ignore these neutrophils. And I get why as we work with them more, because they die quickly. It makes them very hard to work with in the lab. But they're those kind of first responders that are coming in. They're kind of like the infantry coming in. They come in fast. They die. They clog up the space, and so that has a big impact in cystic fibrosis, bronchiectasis, a lot of different disease states. And so that's one that we're working on now to look at different signaling cascades. How are different chemokines causing them to migrate in different ways? Now, if we go back in time a little bit, one study that was pretty interesting was this is a little bit more translational, is looking at patients with cystic fibrosis, and there's this thing what we call the bridge to transplant, and that's basically okay. We've seen a drop in the patient's lung function, and they need to have a transplant in X amount of time, or they're going to experience lung death and then pass. And so, what we set out to do was to get a scoring system based on microbial colonization. So, two big ones are Staph aureus and Pseudomonas aeruginosa. And we could kind of pair that while looking at drops in lung function with the aim of expanding that bridge to transplant. Because the more time you have, the better. You have more time to make decisions and find appropriate candidates. That was one thing that was real exciting. Another one that was a little bit more recent was with another one of our fellows, Yaron, and actually my wife helped out with this one as well. She's also a PhD. She focuses more on the microbial side of things.
You always got to plug the scientist's wife, who also
Always.
is a
Always.
scientist. By the way.
Yeah.
It's necessary.
And so it was an interesting one of looking at using next generation sequencing to characterize the microbial ecosystem of the CF lung, and it was the first study to ever do this, where we
Ever of
actually
its kind. Yeah.
Wow.
and so we could look at the microbiome as well as the fungal biome, so we see any fungus that's in the lung as well, and so that was a first of its kind, and yeah, a lot of different things going on.
These are critical areas. I mean, you're looking at CF, about 35,000 people in the country with that disease. And again, some major progress in that disease in the last decade with certain classes of drugs. But those drugs do not stop the disease. And it only apply to about 60% of the patients. Still 40% still have a pretty difficult time, and their life expectancy is cut short. Bronchiectasis, much bigger problem, probably about 200 to 250,000 people in the country, mainly adults. All kinds of things can cause it, and these people get very sick. They have chronic respiratory illness, and they also have a shorter life expectancy. And between the two diseases is this one cell called a neutrophil. So if we can, again, study it, find the right design, and demonstrate that there's some targets here, it will have a major impact for a large number of patients. But again, just the same example of what we try to do here. We're trying to find immediate solutions, but we also want to conduct our science in a way that's based on a lot of applied math, and we're going to do it across multiple disease areas. And again, we do treat the CF patients in our affiliated centers. We do treat the bronchiectasis patients actually at TPERC. And so these are the things that we want to continuously build as we have this house that's focused on rare disease.
Sure. So many people deal with asthma. It's something we talked about off camera. Where are we with asthma and, the new treatments that are out there? What's new in that world? I don't have asthma, but, so many Americans do, and people across the world. So where are we with dealing with asthma?
It is 1 out of 4 people have some type of asthmatic state in their lifetime. I have asthma. I've had it my whole life. We still have the same number of people admitted. They go to the hospital, get admitted to asthma as we had 20 years ago. The same number of fatal events as 20 years ago. So what's changed? What's changed is the number of up and down cycles of asthma, right? So people kind of really getting sick, ending up on steroids all the time, getting all the kind of worst side effects of those. We've definitely solved some of that. The newer classes of drugs are, quite remarkable. They can get people to use a minimum amount of steroids. But here's the problem. These are single targets. This is what Big Pharma is great at. Hey, we found a target. We're going to give them an injection. That'll knock that thing down. We have some good outcomes. We can run the money behind that. And now we have a system that makes, gets these patients better, also makes money. The problem is that the lungs of these patients, if you actually look at them in detail, don't get a whole lot better. So their lung function stays kind of low. And then now they're aging with really low lungs, right? Low function lungs. So now they're 50 years old and their lungs look like somebody who was 80 years old and smoked. So that's not a great outcome, right? And so these are, again, additional questions that we like to study at TPERC. This is kind of population health-wise. But if we don't address all of the questions, right, and really be honest about it, transparent about it, we're not doing our job. And again, this is not putting any criticism towards the pharma companies who are trying to make a difference. Wonderful, right? We all want to have as many of those as possible. But let's look at this, not always trying to say we need a cure first. Right? I feel like this is the number one issue we have in science is this. In fact, we were just talking about this the other day. I sent him an article that talks about how the blueprint for life is not genes. Think about it. The blueprint for life may not be DNA. Yet for the last 70 years, we've always said, invest money. It's all about DNA. Figure out the DNA. We have the solution. We now know, I mean, we've been saying this for a long time, that's not where we should put all the money, right? And ultimately what this comes down to is this idea, I think it's a very much an American attitude thing. America's the greatest country on earth, absolutely. But this idea that, hey, unless we get to the moon, it's failure, right? Unless it's a cure, it's failure. I think this is where we're at. We are constantly trying to shoot for, the absolute, only hitting it less than, 0.1% of the time. Yeah. Why don't we go for, a silver or a bronze, and get better at what we do and actually make everybody better. And you'll hit your goals more often that way.
Sure.
Yeah, that article was really interesting, though. I mean, but it was interesting because you go through it, and a lot of it, they were talking to biologists, but a lot of it were stuff that the people have known for a while. So my take home, if it was like to put that whole thing into one sentence, is like, be careful with metaphors. Seems to be like what that article was about. Like, because it is, especially when you're a scientist or physician talking to the lay public, it's tempting to rely on metaphors, and that could grossly oversimplify, and you never know which hook of the metaphor the public's going to grasp onto, and then never let go, and then it's harder. So sometimes you have to give the public more credibility and trust them to understand complicated issues. But it's it always comes back. There's only so many hours in the day, right?
That's why I think that term cure, is like you have to be very careful when you use that term. It has a very clear definition medically and clinically. Yet I think, you hear other nonprofits and it's, cure this disease or a walk for a cure.
Right.
It's wonderful. It's aspirational. But, if you're a pharma company and you're telling people you have a cure, well, I'm sorry, it better result in a cure. Otherwise, let's call it for what it is. Call a spade, right?
Yeah.
So, I mean, ultimately, these are all the dynamics around rare disease, especially because I do feel that, it is hope that ultimately drives these communities to say, hey, let's start a nonprofit. Let's go raise some money. Let's give it to pharma so we can hopefully get something out of this. We're not taking that approach, right? We're taking this as a holistic approach in the sense that we combine the data science, the research science, the clinical science all together. Study it up, down, left, right, any other angle possible, and let's try and find solutions. And then we partner with pharma, we partner with large clinical systems, and then find a way to kind of get those solutions to the people as quickly as possible.
Wow. It seems as if there's another strain of COVID that's kind of ramping up again. I'd love to get both of your thoughts on that and, thoughts on the future of
Why don't you talk about how we dealt with COVID so differently?
Oh, yeah.
When it first started.
So the first go around back in 2020, we were just getting the biobank off and running, and so we had some samples, and we knew. I don't know if you remember, but back then there was a lot of talk of, is it? Do you have these people that are not showing any symptoms, and maybe it's just running through our populations? And so obviously a lot of parents were concerned if their kids were at increased risk, food allergic patients. And so we got an emergency IRB authorization to quickly go through and assess antibody production to SARS-CoV-2.
And IRB, that's the board that...
An institutional review board, yeah, thank you. Basically, it's third-party oversight, which is a really important part of science. We have skin in the game, so it's good to bring in a third party that says, hey, we've looked at what you want to do. We think it's warranted. You now have the go-ahead. And so that's what we attained, and then we were able to quickly, and when I say quickly, we mean quickly. It was, March was the initial lockdown. We had this study going, approved mid-April, and published later that summer that was showing that, our food allergic kids were not at increased risk for SARS-CoV-2.
Which was critical, right? Because we obviously do a lot in the food allergy space. This is a time when the U.S. government said, shut down all clinical activity that's not in a hospital dealing with COVID. Right. We did not do that. We built a safe environment. We built the testing, tracing, tracking aspect. But then we had the research, the actual research that showed these kids are actually going to be safer with COVID regardless. And so we stayed open. We kept the patients coming through. And I think that was a model really for everyone else. But again, it goes back to disruption, right? It goes back to the idea of saying, hey, are we going to accept this, or can we find a real opportunity to solve this problem immediately?
And both sides stayed open. So the Food Allergy Institute as well as TPERG.
That's
correct.
The whole entire time.
Day.
That's correct.
Yeah. Yeah, and it was wild time too, because I've been doing ELISAs for 18 years at that point, and now all of a sudden everyone knew what an ELISA was,
That's right.
antibody-based testing.
That's
So
right. That's
yeah,
right.
it's
Wow.
kind of crazy.
The future of TPERC. What do you see, Dr. Marsteller?
So I mean, we're started as a nice kind of startup the first couple years. Now we're in this nice growth phase. I mean, I see next is just expanding our core facilities. Right. I think the next really exciting one would be to get more into some of this agricultural space. So if we're going to look at expanding our arsenal of tools to use for biosimilar protein immunotherapy, bringing in a agriculture scientist, a botanist coming through that really understands the plant proteome, that will be a huge benefit. And then we could start to characterize some of these new tools down the road as well. And then that will also lend itself to, as our biobank becomes more robust, because then we'll be able to actually look and assess binding from allergic patients. And then we also have the ability to look at cross reactivity. So maybe we have a patient that isn't allergic to a certain food group, but we could still see binding. But it's all going to come together with this, we come at it from the immune system side, and then we start coming at it from the, farmland side.
Yeah. Does one have to be, last question for you, does one have to be a genius to even begin to tackle something like this? I've asked Dr. Randhawa if he thought he was a genius. I'd love to get your thoughts on that. Do you think you're a genius?
Well, I think I've taken the test before, the Weiss 3, and I'm pretty good at putting puzzles together under a time crunch. But I think to be a successful scientist, you gotta put in the work, and you have to know your limitations and work every day to reduce them a little bit. And so I think that's more important than how quick you could assemble a series of pictures into a storyline.
Okay, so but what did your test reveal?
I had like a 141.
Okay.
Yeah, but
There you have it.
That's solid. That's solid.
but yeah, again, it's just like doing puzzles and stuff. So if you need someone that could look at two pictures and tell you which kitty cat has a bow tie on, I'm your guy.
Okay. Dr. Randhawa, did you have anything else for Dr. Marsteller?
No, I appreciate you coming out today. I think the future is very bright for us. I think we're going to keep pushing this agenda. We're going to continue to add more rare diseases into our arsenal. And I just tell everyone, stay tuned and keep an eye on this guy.
Yeah.
We'll take it to the next level.
Well, as a layperson, thank you both for what you're doing in this wonderful world of research and all these premature babies that you're helping out. And so excited to see what's going to happen in the future.
Thank
Thank
you
you
for
both.
having me. Appreciate
Absolutely.
it.
Awesome.
Thank you.
All right. Thanks,
There
Sean.
we go.
All right.
Appreciate it.
Thank you for watching Disruptive RX with Dr. Inderpal Randhawa. We'll see you soon.